So in this video, I'm going to show some examples of how to do finding the measure of angles and sides dealing with regular polygons. Okay, so for all of these, they are going to be regular polygons so that we know. Okay, you can't find the measure of a single central angle or exterior angle or interior angle if it's not regular. So they don't specifically say in these problems, but on like the exam or on the homework, they should specify that it's a regular polygon. So let's just go over a few of the formulas because we are going to need them to do these problems. So when we're talking about regular polygons, it means that all the sides and all the angles are equal. And we had like kind of 3 different angles with regular polygons. I'll just draw like a pentagon. It doesn't have to be a pentagon. I'm just doing an example. So it's not necessarily drawn to scale, but we would say all these sides are equal and all the angles are equal. And we have kind of 3 different angles when we talk about polygons. We have this interior angle, which is created by 2 sides of the polygon that come together at a vertex. We have the exterior angle. Okay, and there again is, you can make an exterior angle at any of the interior angles. So this pentagon has 5 interior angles. It also has 5 exterior angles. You just draw by extending one of the sides. And then there's the central angle. So the central angle is if you make a point in the middle and you draw and you split the pentagon into equal triangles. So if it has 5 sides, you can split it into 5 equal triangles. And then these 5 angles are the central angles. Those are our types of angles, just as a reminder. And our formulas, as just a review. So the interior angle, again, there's 2 ways. So actually, let's start with the exterior angle. So the exterior angle, because it's a little bit easier to find that, it's 360 divided by n, which is the number of sides. The central angle is always equal to the exterior angle. So it's the same thing, 360 divided by the number of sides. And then the interior angle, you kind of have 2 options. The interior angle, you can do the longer formula, which is the number of sides minus 2 times 180. And then you divide that whole thing by the number of sides. Or kind of the easier way is that the interior angle is equal to 180 is equal to 180 minus the exterior angle, or the central, because they're equal. Okay, so this is the interior angle. Because as you see in the diagram, the interior and the exterior angle always form a straight angle, so they add up to 180. They're supplementary. So those are just a review of the formulas kind of quickly. We will go over them in class. So we want to find the measure of one central angle of a dodecagon. Okay, so we always need to figure out the number of sides. A dodecagon is 12. Central angle is this formula. So it is 360 divided by 12, which is 30 degrees. So that's the central angle of a dodecagon. The second one says find the measure of one exterior angle of a regular 13gon. Okay, so 13gon, n is 13. One exterior angle, again, it's kind of the same formula. 360 divided by n. Okay, and that is we'll just do 2 decimal places, 26.69. Okay, so that's an example of a central and an exterior. Okay. So then we are going to look at finding interior and sum. So this one says find the sum of the interior angles for a decagon. And for sum, it doesn't have to be regular. It could not be regular and it would be the same formulas. So a decagon is 10. And for the sum of the interior angles, you do always have to use this formula. So let's go over the sum. So the sum of the interior is the n minus 2 times 180. The sum of the exterior is they always add up to 360. And same with the sum of the central is 360. So sum of the interior is n minus 2 times 180. So we would do 10 minus 2 times 180. So 8 times 180, which is 1440. Okay, so the second one, find the sum of the measures of the exterior angles of a hexagon. Well, for exterior angles, the number of sides does not matter. It is always 360 if they're asking for the sum and the exterior. Okay, and then the last one says find the measure of each interior angle of a nonagon. A nonagon is 9. And so again, for interior angle, if we just go back to the last slide, you can either use this formula or you can use this one. So I'll show both ways, it's just up to you. So if I just do the straightforward for the interior angle, we do n minus 2 times 180 over n. So that would be 9 minus 2 times 180 over 9. Now, if you have a TI or like a fancier scientific, you can type this all in at one time, but make sure that's in parentheses. If you don't, or if you think you're going to make a mistake, I would do it in pieces. So you always do parentheses first. So 9 minus 2 is 7. And then I would do 7 times 180, which is 1260. So that's the sum. This top formula is the sum. And then we're dividing it by the number of angles because they're all equal. Because again, this should be, we're considering this a regular nonagon. And so that would be 140. Okay. Now, if you don't like that formula, what you can do is you can always find the exterior angle, because that's a little bit easier formula, which again is 360 divided by n. So you could do 360 divided by 9, which is 40. And then to find the interior angle, if we know the exterior, we can do 180 minus that exterior angle. So we would do 180 minus 40, which is 140. So that's two different ways to find the angle measures. So that's a few examples. Again, if you have questions, just let me know.